Right. Do you have to? No, I know that it's instead of minusing one from the power, you add one.
Yeah.
But I can't remember what you do with the number in front.
You divide by the new power.
Right. So is it just x cubed?
So it's going to be x cubed, and then you divide by the new power.
Oh, divide by. So 1/3 x cubed.
Yes, that's a good way to write it as well. And so b?
1/7 x cubed x 7.
Yeah, and then about c.
Is that a half x squared?
Yeah. D?
Is that minus 4? Does it say so?
Yeah.
Is it minus 1/3 x? The power minus 2.
Yeah. Any idea about e?
Just 2.5 to the squared.
So if you integrate, what is the derivative of 5x?
Just 5.
Okay, so what's the integral of 5?
5x.
Yeah. So integral of 5 is 5x.
Right.
So it's like, what line has the gradient of 5? And the answer is y equals 5x. And all of these have a plus c after them.
Yeah.
F?
Who's f3x, sorry?
Yeah. Do you see 3x squared, is it?
No, I can't see, so it's just right. Yeah, perfect. Squared. Is that just x cubed?
That's it. G?
The 0.5 x to the 8.
Yeah.
Half.
H?
6x to the minus 2. Minus 6x to the minus 1.
Yeah. We'll skip this one. J?
Is it? I'm not sure on that one.
So add one to the new power.
So squared. So 1/3 x squared.
Are you looking at this one? I?
No, sorry, I thought sorry.
Sorry, you're right. J, sorry. Yeah, so that's going to be x squared. And then if you divide by the new power, well, if there was no third there, what would it be?
Just a half.
And so it's 1/3 times a half.
So 5th. 6th, sorry.
Yeah.
Added.
J. Skip next one and last one. L.
How do we feel it? K, sorry.
Last one.
Oh, last. Minus. Minus 3/8 x to the minus 2.
Well done. Brilliant. And they're all plus C. Okay. Any idea about the first one? How you do it if there's two terms?
You just integrate them both separately.
Yeah. So what would it be?
X squared plus 3x.
How about question D?
Could you just move it down a second again, sorry, please?
Oh, sorry.
Cheers. Yeah, fine, perfect.
Yeah, so I'll just do that.
Yeah. 1/3 x cubed plus half x squared plus 1x, just x.
Yeah, well done. How would you do F?
Do you expand the bracket first?
Yeah, you just expand the bracket first and then integrate, and so you'll be fine for that. How do you do G?
Same again, just expand the bracket.
Yeah. How would you do I?
You have to put it back into index 5.
Yep.
So, does it just become x to the minus 2?
Yep. So that is the integral of 2 plus x to the minus 2. And so what is that?
X squared plus
How do you get x squared?
2 squared. Oh, it's 2x, sorry.
Yeah.
X squared. 2x plus minus 1x to the power minus 1.
That's fine. Next one's gonna be fine. Next one's gonna be fine. Next one's gonna be fine. So the difficulty there is just expand the brackets and stuff. Okay, different letter and fractions. How do we do 3a?
What is it? Y1? I can't say.
Y to the power of a half.
Right. 1, 2, 3. 3/2. Is it 3/2y? To the power 3/2.
So if you divide by 3/2.
Oh, right. Don't know. Not sure.
Keep, change, flip. Divide by 3/2 is the same as?
What are we dividing it by?
Let's say 1. 1 divided by 3/2. How would you do that?
1 divided by 1 times 2/3.
Yes, and so it's going to be times 2/3.
Right.
So B.
Is that half again? Yeah.
That's 5/2.
5/2. To the y. Uh, 2 over 7y, and then to the power 7 over 2.
Well done. And these are all plus C as well. C.
Two over 1y to the power 1 over 2.
And what is 2 divided by 1?
2.
Yes, so that's 2y to the half. Let's see. Okay, part D.
What's the power, sorry?
A
Third.
A third, yeah.
Oh, 40. Four, I know it's 4 times 3/4. You have the number that's in front.
Yes, 4 times 3/4. Do you have a calculator?
Yeah. So just 3.
Yeah. And what's the power?
4 over 3.
Well done. You're going to be fine for the next one. I think you'll be fine for that. How would you do G?
You have to change it into index forms. I can't remember how you do that.
What is...
Oh, yeah. Would it just be y to the power 4?
Y to the power of?
4.
What would be part A the same as y to the half?
Squared or square root.
That's the same as square root of y.
Yeah.
And so 4th root of y is the same as?
Or y to a quarter.
Yes.
Other ones at 5/4. 4/5. 4/5 y. It's the power 1/4.
Not 1/4.
Sorry, 5/4.
Oh, 4, yeah. So the tricky part there is just converting. Okay, so how about h? Convert that.
I know it's y to a half for the square root bit.
So that's 7 over y to the half.
Yeah.
And when you bring the half up, what's going to happen?
Minus half.
Yes. And so it's 7y to the minus a half. what would be, so and then you would just convert it from there, or sorry, then you would just integrate it from there, which would be alright for part I.
No, I'm not sure.
Well, that's the same as a half times 1 over y, 1 over y squared. What is 1 over y squared the same as?
Y to minus 2.
And so that's the same as a half times y to the minus 2. And simplify that.
Lost a bit.
So just the short way of writing it would be a half y to the minus 2. So basically, because of BIDMAS, the power, the 2, is connected only to the y and not to the 2 at the front. And so it's the same as a half y to the minus 2. And you can see that if you split it up into 1 over 2 times 1 over y squared. Try k.
Five over 2 y to the minus 4.
Brilliant. 5 over 2 y to the minus 4. And try L.
Just y to the minus a third.
No. So use your previous answer. Think about it.
1 over 3 y to the half.
And so when it's underneath, it's to the half. And so when it's brought up?
Minus half.
Yes. Well done. And we need to do j as well, but it's kind of a different thing.
It, is that y to the half bracket cubed?
Yeah. So y to the half cubed, or y cubed to the half. And can you simplify that? Power to a power?
Is it just plus?
No.
Times.
Yeah.
3. 3 over 2?
Yeah, that's it. Okay, any questions about anything there?
No.
And integrating y to the 3 over 2 isn't difficult. It's just kind of getting it into that thing is the tricky part. Let's see. So question 4 just has 2 terms, and they don't look any more difficult. No. There's one. How would you do question G?
Which one? Question
G.
Would you bring the t up before you do anything else?
Okay, so what would you get?
T squared plus 2.
Fine. T squared plus 2, and then you just integrate that, and it's quite easy to integrate. Let's see. What about I?
No, I'm not sure. Would you integrate everything?
You'll do the same thing you did a second ago.
Yeah.
So you would bring the 2p up, or another way to think of it would be 4p to the 4 over 2p minus p squared over 2p. So what is that same as?
That's the same as 2p squared over 2p. No, it's just 2p squared.
So simplify this fraction.
2p to the power 4.
So those, I cancel like that. P to the 4 over p.
2p to the cube to the 3, so.
Yeah. Anything you can do here?
Yeah, there's the p. Once you come.
Yeah. Okay, so when you simplify that, it becomes 2p to the 3 minus p over 2. And then how do you, what would be the integral for that?
Half p to the 4. Minus. Does that become p to the minus 2?
It's currently p to the 1.
Right. So p squared.
Yeah.
So is it a half p to p squared?
Yeah, you could write it as a half p squared over 2. Or what is a half divided by 2?
A quarter.
Yeah. So it's basically, that's like a half p, and so this is a quarter p squared. Yes. So that's I. Let's see. That one. Okay, how about k?
I'm doing the same thing again and just dividing it by the 3x squared.
Yep.
So for the 6x squared bit, would it just become 3?
Yeah.
Sorry, 2.
So that's going to be 2. And the other bit?
3x squared. 1 divided by. No, is it? No, what's 1 divided by 3x squared?
Okay, so it's 1 over 3x squared.
Yeah.
How could you write that in polynomial form?
I don't know. I'm not sure.
That would be 1/3 x to the minus 2. So the squared is connected to the x only.
Right.
And then you would go from there. So that's k. And then we'll try L, very last one. Oh, hang on, I'll make some space here. Hopefully, so I'm just not sure if you can see it. We'll try L.
You convert the bottom bit to 2.5.
Yeah.
The power half to. 2, T. I'm not sure about the first bit again, about 2t divided by t.
So that would be the same as 2t over t to the half and plus 3 over t to the half.
Yeah.
How do you work out the first bit?
So I'm not sure. 2t divided by t to the half.
What's the index rule for that?
No idea. Can't remember.
Subtract.
Subtract.
Yeah, for dividing indices.
Right. Oh, for dividing in? Alright, yeah. So, minus half.
So you have t to the 1 minus a half?
T to a half.
Yeah, so it's going to be 2t to the half. And how about the other one?
3. 3 divided by t. Three t. No, I don't know.
So if you bring the t up,
3t to a half.
so it's a half underneath.
So minus half.
Yes, that's it. So this is more, I think your difficulty with integration and all that stuff is indices. How would you put f into polynomial form?
What's the power of 2x, or is it 4/3?
Yeah, so that's already polynomial form. That's already polynomial form, and it's just the last one.
7 over x squared. Uh, 7x to the minus 2.
Yep. So that's going to have 7x to the minus 2. How about g?
X to the minus 3.
So it's going to be x to the minus 3. but the 3 is connected only to the x.
Alright, so a quarter.
Yeah. And
then 2x. 2 over 2/3 x minus 2.
Well done. Yeah, I think you're good there. So let's say part C for this one.
Let's see. 4/3 x to the minus 3.
Minus 3. How about E?
3x to the minus half.
Hold on. How about G?
Oh, wow, you earlier.
3 minus x squared over 3. Minus 2.
Sorry, just a sec. Go, let's close the door.
Alright.
Sorry, go on.
Is it 3 minus x squared over 2?
So you have to, because there's a plus or minus in between them on the top, you have to divide them both by that. So what would that be?
Three over 2x. 3 over 2x to the minus 2.
Yeah.
And then is that just 2 minus 2?
Close. If I was to cancel those 1 over 1.
What's a half?
Yeah, that's it. That was G. What would be I?
I got 9x 2/3 for the first bit.
Okay.
And then.
So is it? So that's x to the 2/3 over 3, was it?
It were 3 root x, yeah.
Okay, go on.
Minus 3. I'm struggling a bit with that second bit again.
That's the same as minus 2 over 3 root x.
Yeah, got that. So I don't know where to go from there.
What is x root x the same as?
X to a half.
So that's the same as minus 2 over 3 x to the half.
Could you go even more? Could you go to x to a third?
No. So that would be the same as if you bring the x
up. Minus 2 over 3x to the minus half.
Well done. Minus half. That's it. And what's 9 over 3?
Just 3.
Yeah. So that can get even simpler. And so how do you go from having dy dx to just y equals?
Integration.
Yeah, you just integrate it. And so we're not actually doing the integration bit because it's not difficult to integrate 3x to the 2 over 3. It's just the difficulty we're having was with the index bit. Let's see. Given that, okay. So we'll see how you are for this one. What is this one about?
Integrate first, so which becomes x squared plus 1x.
Mm-hmm.
We're doing part A first, yeah.
Yeah, and the bit we always leave out is the plus c.
Plus c. When x equals 1. And do put x equals 1 into the equation.
Yeah.
I see. So 1 squared is 1 plus 1. 2 plus c.
Right.
We've got y as well, so 5 equals 2 plus c. So c equals 3.
And so what's the equation of this one? Y equals
x squared plus x plus c.
What is c?
3 plus 3.
Yes, that's it. And so if you have a coordinate, you can actually find what c is.
Yeah.
So I think you're good for that. That's the only thing that was asking. They're all very similar. And what you'll notice is when they start getting to this kind of harder integration questions, the integration itself becomes easier. Like it's pretty simple because it'd be like too difficult if it was all sorts of stuff going on.
Yeah.
So that's a pretty good one. Might not be. Okay, so sometimes they say find the value of y when x is 4. So how would you find the value of y when x is 4 for this one?
Put x into the equation.
Yeah, and so it'll be 4 squared plus 4, and now we have plus 3, and we can find
Okay.
y that way. Yeah,
Yeah.
okay. So you're actually pretty fine, I think, for the integration bit itself. How would you go about finding the equation of a tangent to a curve?
I don't know.
Try it. So what do you think about this one?
There's an expression for f of x. We'll integrate the 2x cubed.
Yeah.
Yeah. Half x bar.
Yeah.
Well, minus minus half x squared. Minus 8x. And then that's plus c as well, isn't it? So plus c. We've got y. Y is 4, so 4 equals half minus 1.
Yeah.
Outside the bracket is the power 4 minus a half minus 1 again squared, and then minus 8 minus 1, and that's plus c. So 4 equals 8 plus c. So c must equal minus 4.
Yeah.
And an expression for f of x. So the expression for f of x would it not just be half x to the 4 minus half x squared minus 8x minus 4?
Yeah. Any idea how you go about part B?
Equation of the tangent. The x coordinates. No, is the tangent is it perpendicular or is it negative reciprocal?
So
Isn't it?
that's the normal.
Right.
So what do you know about gradient of a tangent?
Great. Is it going to be 0?
That's a stationary point.
Alright. Tangent. Well, about gradient and tangent.
It's parallel. It's the same gradient.
Alright.
Even it was perpendicular. So what is the gradient? Well, how do we get gradient? Gradient of what?
You differentiate for gradient now.
Okay, and so when you differentiate what do you get?
Which bit we differentiate?
So let's say you differentiate the f of x. What does that give you? So just in general, if you differentiate, what's it called when you?
It just gives you a gradient.
What do you know the name of it? Instead of f of x, it becomes
The derivative.
So
No,
dy dx.
yeah.
Do you know the other name for it? It's similar to f of x.
No, I don't know the other name.
F dash of x. And so if you think about it, they already gave us the derivative and we integrated it.
Yeah.
So if we do the derivative of f of x, it'll just be this again. And so how do we use that to get the gradient?
Gradients. Well, I'll put 2 into that bit, the f dash x.
That's it. So you do f dash of 2 and you put in 2 instead of x, and that gives you the gradient. So I think it's 6. And then how do you use that to find the equation of the tangent?
The equation, is it going to be y equals mx plus c?
It could be. An easy one might be y minus y1 equals mx minus x1.
Y minus. I can never commit that to memory, I don't know why.
It's basically if you multiply both sides for the y2 minus y1 over x2 minus x1.
Yeah.
You get it?
Y minus y1.
Yeah.
Do you do the y minus y1? So y minus 4 equals m, just 6. X minus 1, so that's plus 1. So y minus 4.
Hold on. They said, so that would be, you're thinking of the gradient, you're thinking of the equation of the tangent at the point minus 1, 4.
Oh, yeah.
They want it when the x-coordinate is 2. So different point.
So, but keep the y the same.
The y won't be the same if it's a different point. So basically you don't know the y and you need to find it.
Okay.
When x is 2.
Oh, I got a loss.
The way, how do you find the y coordinate if you know the x coordinate?
I can't think, I don't know.
So this thing that we found, the f of x, another way of writing that would be y equals.
So what? Oh, so just put the x coordinate into the equation we've got.
Yeah. And so we would do the f of, so what x are we putting in?
2.
That's it. So we would do the f of 2. So what's it gonna be? 8 minus 2 is 6. Minus 16 is minus 10. I think it's minus 14. And so what do you do there?
Minus 14. Then can you use the equation at the top? Y minus y1.
Yeah.
So y plus 14
Yeah.
equals 6 x minus 2.
Well done. That's it.
Is that it?
That's it. That's the equation of the tangent. So equation's got equals, it's got y, it's got x. Okay, so this is a pretty great question. So they give you the f dash of x. You have to find the f of x. And you do that the normal way. Integrate and then sub those in to find c. And then you have to use that to find the equation of a tangent when x is 2. So when x is 2, sub it into the thing we just found to get y.
Right.
Sub the 2 also into this gradient function to get m. And then sub y, m, and x into that. Any questions there?
No, okay.
So it's easy to get lost in the longer questions, but it's a pretty good one. Let's just see. If a curve passes through the origin, what coordinate does it go through?
0.
Yeah.
0. 0,
Yeah.
0.
So that would allow you to find the f of x. That would be your point to use. Find an expression. Yeah. So if they give you dy dx and they want y equals or f of x equals something like that, you just integrate it. Constants. Okay. Integration. So those are similar. The gradient. Those are similar. So that's that one, and I'll just see. So that's like, believe it or not, that's like the first half of integration, is it?
Alright.
I just want to see what the second bit looks like. And you're doing OCR, isn't it?
Yeah.
Let's see what this is. Yeah, so how do you integrate between limits?
No clue, that's completely new to me.
Is it? Okay, that's fine then. So we've done the bit you needed to do. So I'll just take a quick look. Where is it? Yes. So it's always +1 to the power, and then you divide by the new power.
Yeah.
Which is the exact opposite of differentiating and in the same order, or in the reverse order. So with differentiation, you multiply power by coefficient and then -1 from power. So this you do the reverse and in the reverse order. So first you add 1 to the power and then you divide by the new power. If it's x, that's like x to the 1. So that becomes a half x squared. If it's something like 5 by itself, if you're integrating with respect to x, then it'll become 5x. If you're integrating with respect to t, it would become 5t, and so on. And it's because the gradient of the line y equals 5x is 5.
Yeah.
Then the rest of that is okay, I think. I think it's good to do it as the instead of over, to do it times the reciprocal. So -2 times it by -1/2, because it would be weird if it was like a fraction divided by something.
Yeah.
So integrate them separately. Okay, if you have brackets, expand the brackets. Put it into polynomial form. That's not too bad. Expand the brackets, expand square brackets. So to the power of 1/2 is the same as square root. And so 4th root of y is the same as y to the 1/4. And the integrating bit isn't difficult. So what's good about this is we also revised indices and surds as well. So a lot of this is indices and surds. Yes, dividing by a fraction. So part C, dividing by a fraction is the same as timesing by the reciprocal. And so 1/2 becomes times 2y. Let's see. Yes, y part I, why was that a half y to the minus 2?
Because the power is only connected to the y.
Correct, fine. And then you were good for that one. And then this one was a third y to the minus a half. Yeah. Okay. This one, j, yes, power to a power, you multiply them. So that's y cubed to the power of a half. And you multiply 3 times a half. Do these all separately. Distribute out the t on the bottom. This stuff just takes practice, and it might even help to just do them separately. So 4p to the 4 over 2p, do that, and then p squared over 2p, do that, and then just bring them together. And let's see, and that was the same thing. Yeah, so same stuff, just more going on. And as the integration gets harder, the stuff that they use gets a bit simpler. So that was just more of it the same, but just getting more difficult with putting it together. So the 3 is on the bottom, and then the x to the half you can bring up to become x to the minus a half. Yeah, so this one, so we were just kind of doing it the short way before, but now we do it properly and write in the plus c. So any number, when you differentiate, it gets obliterated, and so we just know plus c, but if we know a coordinate, we can actually find what c is.
Yeah.
Then this tricky stuff. So we're given the f dash of x, integrate to find the f of x, use the coordinate to get plus c, and then to get the equation of the tangent, use the equation we just found, sub in 2 to get the y, sub in 2 to the f dash of x to get m, and then sub all 3 in to the equation of the line.
Yeah.
Yeah, how was that for you, Conall?
That was good, yeah.
So that looks like it's integration anyway. Anything in particular you want to do next time?
No, I mean, by next week I should have the results of the test back. I suppose it's just going through that, really.
Okay, and yeah, so I think what's good to practice is indices, surds, and integration. So the integration, there's like little stuff in there, like especially these longer questions, they get a bit crazy. But yeah, the difficulty you were having, I think, was the beginning of it, which was the indices and surds. So maybe you can take a look at those.
Yeah.
Any questions for me in general?
No, just that. I think they're the first chapters. Them like the indices and surds.
Yeah, they kind of get glossed over because people think like, oh, it's just indices and surds, but you need them for differentiation and integration.
Yeah, well, it's not just this either. I didn't realise how much they actually crop up in the topics that I've been doing.
Yeah.
So.
Yeah. Anything else?
No, that's it. I was just going to touch upon that.
Okay. Well, well done, Conall. You did great. I look forward to talking again next week.
Cheers, Dara. Thank you.
All right. Have a good week. Goodbye.
See you later.